So this first example here is just a repeat of the problem we did at the end of the first part of our notes. This one, it says, number 1, what is the range of possible values for the third side of a triangle with two sides that are 13 centimeters and 9 centimeters? So if we start out and just sketch ourselves a triangle, and then we'll say that one side is 9 centimeters, another side is 13 centimeters, and we're just trying to find what could that third side be equal to in order to actually form a triangle. So if you recall, remember what we said we had to do was to write the three inequalities using our triangle inequality theorem. So we could say that 9 plus 13 has to be greater than x. The sum of the two sides has to be greater than the third side. Another inequality would be the sum of 13 and x, which then has to be greater than 9. And then finally, the sum of 9 plus x would have to be greater than 13. So if we solve those three inequalities, the first one we have 9 plus 13, so that's 22, is greater than x. So another way of writing it is x is less than 22. So 22 probably is our upper boundary. The second inequality, if we subtract 13 from both sides, you have x is greater than negative 4. Okay, again, we're talking about lengths of the sides of a triangle, so we would eliminate this inequality there because we cannot have any negative lengths. And then finally, when we subtract 9 from both sides on the last inequality, we have x is greater than 4, which means that 4 is our lower boundary. So our range of possible values for that third side would be that 4 is less than x, which is less than 22. Or as I said, another way of saying that is that x is between 4 and 22. Cannot be equal to 4, cannot be equal to 22, but it can be between 4 and 22. Okay, so now what I'd like you to do is look at these values, 13 centimeters and 9 centimeters again, and see if you can find a relationship between those two given sides. That would be a shortcut to finding the range of values for the third side of the triangle. Again, we're looking at the numbers 13 and 9. And remember that our range of values is that x is between 4 and 22. Okay, so here's your shortcut. If you look at 13 and 9, if you subtract 13 and 9, so 13 minus 9, that's equal to 4. There's your lower boundary. And then if you take 13 and 9 and add them, so 13 plus 9 equals 22, there's your upper boundary. So when you're just given three lengths like that, it works every time. If you subtract the two lengths that you're given, that's going to give you your lower boundary. And if you add the two lengths that you're given, that will give you your upper boundary. So again, 4 is less than x, which is less than 22. In this second problem, it says, what is the range of possible values for x if the set of expressions represents measures of the sides of a triangle? So this is a little bit different because here we actually have algebraic expressions rather than just numbers. Okay, but the process is still the same. What we're still saying is that the sum of two sides has to be greater than the length of the third side. So again, I'm just going to sketch a triangle over here and just label it with these three expressions that represent length. So I've got x plus 2, x plus 4, and x plus 6. Okay, so again, I'm going to write my three different inequalities. So the first one, I would say x plus 2 plus x plus 4 has to be greater than x plus 6. And then another inequality would be x plus 2 plus x plus 6 has to be greater than x plus 4. And then finally, x plus 4 plus x plus 2 needs to be, oops, excuse me. Let me erase that just a minute. Made a mistake here. That should be x plus 6 has to be greater than x plus 2. All right, so now we go through and solve the inequalities again, just like you're solving algebraic equations. I'm going to combine like terms first, so that gives me 2x plus 6 is greater than x plus 6. So if I subtract x from both sides, I have x plus 6 is greater than 6. Subtract 6 from both sides, x is greater than 0. And then if I go to my second inequality, doing the same thing, combining like terms, I have 2x plus 8 is greater than x plus 4. Subtract x from both sides, so x plus 8 is greater than 4. Subtracting 8 from both sides, so I would have x is greater than negative 4. And again, we are talking about lengths, and if I choose a length that's a negative number and plug it in for x, it would not work. Okay, it would still give me some negative lengths, so I'm going to eliminate that option. And then the other one, if I combine my like terms here, I have 2x plus 10 is greater than x plus 2. Subtracting x from both sides, x plus 10 is greater than 2. Subtract 10 from both sides, x is greater than negative 8. So again, here's another negative value. So I would eliminate this. So what this means for this particular triangle is that there is no upper boundary. As long as we pick any value greater than 0 for x, that will give 3 lengths that form a triangle. And again, you can go through and just try, anything greater than 0. So even if we just put in 1, we would have 3, 5, and 7. And 3 plus 5 is 8, which is greater than 7, so it works. So our solution for this one is just simply x is greater than 0. In your assignment for this section, you will be applying the triangle inequality theorem to determine if lengths will form a triangle or to find a missing length or the range of values for a possible third side.